It's seeming more and more like Google's going to be the big winner of the AI race. We covered Gemini 2.0 a while back when it dropped, and I've been blown away with the model since. It was so good and so cheap that we actually made it the default model for T3 chat, and I'm so happy we did. The performance has been great, the answers have been great, the speed, all the pieces are there, and they're doing something genuinely awesome. All that said, we're not here to talk about Flash 2.0 because Google just dropped a new model, and I'm kind of blown away. Gemini 2.5 Pro just dropped, and everything I'm seeing is pretty nuts. From the speed of responses to the performance it's getting to the benchmarks it's clearing to just slaughtering almost everything else on the market right now. There's a lot of really cool stuff going on with this model, and I can't wait to tell you all about it. But someone's got to pay these bills, so a quick word from today's sponsor, then we'll get right to it. Today's sponsor is Augment Code. And I could just tell you all the things they say on their website, but I'd rather give an actual example that I went through because I've been using it a ton. Augment is great at giant code bases, which is really helpful if you're trying to figure out how a giant code base works. Here's one that I wanted to understand. This is the Rocky Corp monorepo. This monorepo has a ton of code in it for multiple different packages, including the entirety of Replicache and the entirety of the Zero Sync engine built on top of Postgres. I know these engines are really stable, and I wanted to better understand how for my own use in T3 chat. Sadly, this is a giant code base, almost 200,000 lines of code in just the TypeScript portion. This is not something I can sit there and quickly parse through. So I opened up VS Code, cloned the repo, let it index it, which happened surprisingly quick, and now I can ask it questions all about this code base. If you want to see how fast it is, I'll show you in real time. Here's where I asked it, where's the code that stores the data locally for the client side of Zero? If I ask it again, this is all real time. It's almost immediately starting to respond alarmingly quickly with all of the context of this gigantic code base where I can find individual things and answer questions about them. How does this differ from the Replicache storage? Zero Storage is actually built on top of Replicache's storage system, but with some key differences in additional layers. Let me highlight the main distinctions. Do you know how useful this is when you're trying to parse a gigantic code base like this? For reference, the T3 chat code base is 17,000 lines of code. So this is a code base that is 10x bigger, and it's able to answer questions almost instantaneously. Like within less than a second, you're starting to get an answer. If you're trying to onboard onto big code bases or help a team better understand the large architecture of your business, Augment is the company building AI tools for those use cases. If you need help with your gigantic code bases, check them out today for free at soydev.link/augmentcode. So what's going on with Gemini 2.5? 2.5 is a thinking model designed to tackle increasingly complex problems. Our first 2.5 model, 2.5 Pro Experimental, leads common benchmarks by meaningful margins, and it showcases strong reasoning and code capabilities. It's another one of those models that, upon dropping, immediately leads the LM arena, which is pretty cool to see. Wow. Pretty quick that Gemini drops and is immediately number one here, even beating out GPT 4.5 and DeepSeek and all these other very well known to be great models. I have a feeling it's going to be a lot cheaper too. I will say we don't know the pricing yet, but unlike the previous Pro models, they've actually confirmed that they'll have this up and available for priced tiers very soon, which is huge because historically I've been concerned about adding non-paid models to something like T3 chat because it means those rate limits are going to be enforced much more aggressively. If I'm not giving you money, you have no incentive to keep the service up that you're providing. But if I am paying you, you're probably going to keep it around. So very excited for them to add that. All of that said, this has not stopped us from adding the newest models to T3 chat. I did actually hit up our contacts over at Google, and we were able to get Gemini added early, and the rate limits are high enough that I'm relatively confident you won't have problems if you use it with T3 chat. So if you're a Pro subscriber on T3 chat, reminder, only $8 a month, you'll have access to all of the latest models as soon as we can reasonably add them. If you haven't subscribed to T3 chat yet, we'll make it a little easier. Here's a coupon code that gets you half off for your first month. So that's only $4 for 1,500 messages across all of these models. Pretty insane deal if you ask me. Make sure you redeem it quick though, because it's only going to be available for the first 200 people who redeem it. In my opinion, the only cool model we don't have right now is Grok, because despite promising the API for like 2 months now, they've still not shipped the Grok 3 API. It's insane. They're just lying over at the XAI team, and I'm so tired of it. Anyways, Google has been spending a lot of time on different techniques to try and make their models better. All the fun things we've talked about a bunch in the past. 2.5 is all of those things coming together. They combined a significantly enhanced base model with improved post-training. Going forward, we're building these thinking capabilities directly into all of our models so they can handle more complex prompts and support even more capable context-aware agents. Up until this point, the thinking feature in previous Google models has been one of those like patched on pieces where they say, hey, think about this, and then after reprompt with the actual answer. Now it's a proper baked in thing in the model that's still able to be applied to other models too. I'm very excited to see what that looks like in terms of the implementation. Enough of the tech side though. These benchmarks are crazy. Crushing OpenAI O3 Mini High on the Humanity last exam. That's a big win there, especially considering this exam was largely built by OpenAI to find a better benchmark for LLMs. Google beating OpenAI on their own benchmark is nuts, especially when you consider how good O3 Mini High is. It's been my favorite model for a while now, and I'm curious to see if that changes now that Gemini is shipped a better thing. It's killer at math, which is really nice to see. I've had iffy performance with some other models with math. As you see here, 4.5 sucks at math. Claude 3.7's okay at it. But yeah, it's particularly funny when I consider how bad some of the math responses were with Gemini Flash in the past. So I'm excited to see better math performance here. Still not the strongest at coding. So for you guys who are here looking for an alternative to Claude for code, thinking models still aren't quite at the point where they're a great experience in our editors. I've tried multiple times now with using Cursor and all these thinking models. It just doesn't feel as good as getting a response immediately does. I expect this will be cracked in the future, especially with the parallel multiple agents thing. But for now, not the best experience, and it looks like the results aren't great either. The other problem I've seen with thinking models for code stuff is they'll start to gaslight themselves with that thinking context and do things that they're not supposed to. If we go to the ball prompt, I've seen thinking models convince themselves that gravity is supposed to go the other way and send the ball up instead of down. I think the problem is just that more context is created by the model, which means less context comes from you, which means there's more room for error to occur because there's more space that hallucinations are occurring within. I do want to quickly show my results on this test, though. We open up my cursor here. So you see I have a bunch of different models generating different versions of that test. And here I'm going to run the Gemini version, and you'll see it does pretty well until it doesn't. I was so sad because it seemed like it was going to work great. And then it just, does great until it hits a corner at the right angle, and then it just falls out. Yeah. And for reference, I have another video coming very soon. DeepSeek just put out an updated version of their V3 model, and it had one of the best answers I've seen to this prompt yet. It just works. It's not super well animated, and you can see it has the issue where it rolls and is about to fall out of the container, but it gets bounced back. So it's working much better. But others have been doing the same prompts in more elaborate versions against all the different models. And Flavio here is the creator of this ball in the hexagon concept. I know it's a silly thing, but I do actually quite like it as a gut feel benchmark for how well can this thing code or not. It's obviously not an end-all be-all. It's not representative of the experience you'll have using it in your editor, but it's a fun benchmark I think we can learn a lot from. And as you guys just saw, the Gemini version still has balls falling out of the hexagon. Good overall, though. But as a general model, this is really good, especially when you consider all the functionality that Google includes. Google models tend to have a handful of things that are really, really nice. They have their grounding feature. Grounding is just their code word for search. It has image parsing, which is super, super handy. They recently added image editing, which is super cool. One of the most underrated features, though, is that 1 million token input context window. This is nuts. The fact that you can hand 1 million input tokens to something is still unbelievable. When you consider that each token is 4 to 6 characters, that's a ton. The biggest other reasonable models tend to support is 100,000 to 200,000. 1 million means you can do things you otherwise wouldn't be able to. Something I recently did, and this is a real example, so I'm going to walk you guys through it with me because I was blown away when this worked. This is the Bill Diffrin blog. It's a music blog that I really like. This blog gets updated not often enough. It's a crappy Blogspot website that embeds all of the YouTube and SoundCloud embed things directly into the site. And it is rough to navigate, and it's barely usable at all on mobile. I wanted to turn this into a playlist. So what I did is what any normal engineer would do. I grabbed the source. I went here. I talked to Gemini Flash, and I said, I'm going to give you some HTML with a bunch of iframe embeds for YouTube and SoundCloud links. I want you to write a JS script I can paste into the console to get all of those links. So given it the instructions, now I'm pasting this insane amount of HTML. I'm not going to code block wrap it because it'll break our parsing a ton, because this is massive, massive, like unpleasantly so. It's going to break my sync. It's so massive. I just did this as a test because I was hoping it would be able to see the formatting from there. Here it gives us the JS we can run. What it did for me before that I was blown away with, I'll just show you because it didn't do it this time. What is the expected output? And here it correctly extracted all of the links. It just did this unprompted the first time, and I didn't believe it. So I took the script and I went and ran it and confirmed it did it correctly. Here is the actual chat history I had where I first did this. As you see, the HTML isn't there because it broke in sync. But when I scroll here, it gave me the output code that I can run in my terminal or in my console, and then correctly got all of the links out of that giant pile of HTML. I was blown away. That's something that I just didn't expect models to do right, and that's why I instinctively ask it to give me the code to do it instead, because I don't expect it to correctly generate something that's that complex. But it's pretty nuts that it can figure that type of thing out, and it's been mind-blowing for me as a resource. I've been using Flash as my default model for a while now. But should we try this taking advantage of the new model? I am curious to see how well the new thinking model does here. 2.5 Pro, grab the HTML again. Cool. Oh, it already wrote the code without even having the HTML. Here's the HTML. Show me what the output should be. Remember, this is an absolutely disgusting amount of information that I'm passing it. 71,000 tokens, 222,000 characters. So theoretically, that, even at its insane size, would fit in other context windows. Maybe. Certainly taking his time thinking on this. According to chat, it's also good at image extraction. Thank you, Christian, for the context there. That doesn't surprise me. That does remind me, though, there are other features that Google does that make it an easier default every time I reach for it. They have native PDF support. And the things you can do with this are nuts. It's able to go through just absurd amounts of pages, and it can parse images, graphs, and charts from the PDFs too. Most other image parsers built into APIs for these AI models doesn't have that level of capability. We got our answer here. Found 61 iframes, checking sources, and here it correctly spits out all of them. 61 iframes total, 60 of them have source attributes containing either YouTube or SoundCloud. Awesome. I'm pumped. I will be using this a lot. They also claim that they've been focused on advanced coding stuff, even if they're not quite as good as some of the other models. The progress appears to be nuts. I've had 50-50 luck with Gemini, especially the Flash version with code stuff. So this seems to be a really promising win. Apparently the custom agent setup helps it a lot too. Did they do a vibe coding game example? Really? We got to watch this. Oh, no audio. Nice. That is not bad for a one-shot at all. It's funny how much they've been bragging about what they call their zero-shot generations, where it figures it all out with very little effort, and it seems like it's doing good at it. One other fun thing that I'm actually quite excited about, there's a 2 million context window coming soon, which is just insane. That's going to handle most code bases fine. Like, I've been seeing what a code base of ours flattened into tokens looks like, and some of them are even under 100,000 tokens, but most would be under 2 million. Just imagine the model having context on your entire code base without all these other tools like RAG and lookups. Very, very impressive stuff. So why is Google so far ahead? Why are they able to make these models this good, this fast, and this cheap? There's a handful of things that determine how well models can work and run. I want to break these down to help emphasize why Google is so well positioned. In order to make a model perform well and run great, you need a couple key things. You need data, you need hardware, and of course, you need science. These are the three pieces that determine how well an AI model can possibly perform. All the different sources of data and the quality of that data, the filtering you do on that data, the categorization, and All of that is essential to the success of any given AI model. It's basically impossible for an AI model to be smarter than the data you give it, so you need a lot of it. You might see where this is going. Next is the science, the actual people who know the techniques and technologies to make all of this possible. The science behind LLMs is both pretty simple and rudimentary and incredibly complex and hard to understand. It's a whole field that has been studied for decades now, and Google's historically been a leader in that field. You could make the argument that Google Translate was one of the first real examples of an LLM trying to create paths of what word is most likely to be next based on previous inputs. Google has a deep history of doing this type of science and machine learning stuff, which benefits them greatly. And then we have hardware. Historically, we've relied on NVIDIA GPUs and CUDA for all of the training, generation, and eventually inference when you're building these models. We do that largely because these GPUs are good. They have a ton of chips on them that can go relatively fast. The sheer number of compute units that exists on a high-end GPU makes it possible to do large transforms against insane amounts of data. But NVIDIA is not the best it can get. There's a company you guys might have heard me shill a few times on here, Grok. They're one of a handful of these types of companies that are trying to build better chips for inference. The task of parsing through an insane map of words to figure out what word is most likely to be next is a challenge, and it's a challenge that GPUs are surprisingly good at, especially compared to CPUs, but theoretically, we could have chips that do it better. If you were around for the chaos of Web3 and crypto mining stuff, you might have remembered the ASIC revolution. Initially, when you were mining cryptocurrencies, you would use GPUs, and all mining was taking this complex math problem to break a block to verify the next set of transactions. And a bunch of people would run against it, hoping they'd be the one to crack the code for that block and get the payout of a bunch of Bitcoin. That was done on GPUs because they handled the type of math well. But eventually, when crypto got valuable enough, a handful of companies started to build specific cards and specific chips just for doing that type of math better. If you know the exact format of a math problem, you can architect your chip around it to perform better. And that's what companies like Grok are doing. The reason Grok's inference is so hilariously fast is they're using chips that were built specifically for it. And to be clear, Grok with a Q is not the same as the XAI Grok with a K. Entirely different. Grok with a Q does chips and hosting for models that they didn't make. We actually use them for a bunch of stuff in T3 chat. So if you want to see just how fast it can go, let's hop over to the DeepSeek R1 Llama Distilled model, solve advent of code 2021 day 5 in Python. Do you see how fast this is going? I can barely scroll to keep up with how fast the thinking is going. And if I close it, you'll see as soon as the answer is done, just how fast it can go. Yeah. It's pretty stupid fast. You can't even keep up with how fast it goes. This is because their chips are really, really good at this type of thing. They're not as flexible, though, because the chips have built these expectations. There's a lot of models it will not be able to run, but then there's a lot of models it can. While it can't run standard DeepSeek R1, it can run the Llama Distilled version because it was built to work with models similar to Llama and Qwen. So it handles Qwen and Llama pretty well. It doesn't handle R1 by itself well, but R1 distilled on Qwen or Llama, it can do great. To emphasize how big the win of your own hardware can be, look at how much faster Gemini is than all of these other models. It's absurd. Gemini Flash is so fast that it almost felt irresponsible to not use it as our default model because it's so much faster than anything else that's a traditional cheap model. The only companies that get close are ones like Grok running these older models really quickly on their dedicated hardware. Having groundbreaking models with groundbreaking speeds is kind of a Google exclusive thing right now. And when you look at this intelligence versus speed graph here, the only thing in the green section is 2.0 Flash, because everything else is significantly slower or significantly dumber. There's a reason I shill 2.0 Flash so hard. It's a very, very good model that's performed wonderfully for us. Shout out to Artificial Analysis for all these awesome charts and data, by the way. These guys make my life much easier as I try to highlight these things. I should show cost too quick, though, because it's really funny how much O1 breaks this chart. It basically isn't a good chart until you turn off O1 because of how far off to the side it is. Gemini Flash here is as far left as Nova Micro and Llama 3.1. If you've never heard of Nova Micro, there's a reason. It's a bad model. But it's even cheaper than 4.0 Mini, despite being quite a bit smarter. I'm excited for these charts to get updated to include the new Gemini model, but even here you can see the insanity of the intelligence to price. And when you combine that with the speed chart, it's like, why would you ever default to anything else? I'm at the point where we're probably going to change how Gemini is tracked in T3 chat, so it's not part of your 1,500 message limit, because it's so cheap and so fast that I don't want people to ever worry about hitting a limit with it. So why am I talking about this other random company? The reason is that Google is also building their own chips. Google is the only big AI company that's doing its own hardware as well. OpenAI isn't, and they don't have the right people or history to do it. Obviously, Anthropic isn't either. There's a couple other companies like Grok that are doing hardware really well. And I should just put some of the examples. We have Grok, Cerebras, Samba Nova, I believe is one. These are all companies that are focused entirely on the hardware. When we go to the data, we have companies focused just on that, like Data Curve, Scale AI, and there's a bunch of others that do nothing but data collection in order to make it easier for these companies that are training their data and training their models to get the stuff that they need. And then the science. This is obviously companies like OpenAI, DeepSeek, Anthropic. Historically, companies in the space focus all in on one of these parts and use that as their lever. OpenAI, DeepSeek, and Anthropic are making groundbreaking models because they're all in on the science. Data Curve and Scale AI are collecting data that all of these companies need, and they're all forming contracts with them to get the data they need for their training. And on the hardware side, Grok, Cerebras, and Samba Nova are all just super focused on making the best possible hardware in order to run these models. There's one other company that needs to be put at the bottom of all of these. Google is the only company to meaningfully do two of these, much less all three, which positions them incredibly well because they have an infinite set of data from decades of running the internet. They have some of the best scientists in the world building incredible tech, and the scientists can work alongside the hardware guys in order to make sure the model is built to run as well as possible on the custom hardware that they're making. And this super tight relationship between the science side and the hardware side is something that no one else has, especially when they also have the data on the other end that they can use to train the model in the first place. The only thing I've seen close to this level of like synergy and cohesion is Apple. And they're obviously not figuring out the AI space as we've seen with Apple Intelligence. But Apple is one of those few companies that has the hardware and the software together locked in, where they know what devices are going to run their software so they can make assumptions that somebody like Microsoft can't. Google is doing the same thing here. Since Google's not releasing their models as open source for others to run on NVIDIA GPUs, they can assume that their models are always going to run on their custom Google chips. That assumption lets them do a ton of stuff that no one else can reasonably do. Every other company has to partner with one of these guys. I should also put in NVIDIA. So everyone else has to partner with one of those chip manufacturers. Google doesn't. The science groups have to buy data from other places. Google doesn't. These data companies that spend all their time trying to find people to sell their data to, Google doesn't. Google is incredibly well positioned here in a way that no one else in the industry really comes close to. And I expect this to continue to result in crazy wins on Google's side, be it the incredible performance of the models, the speeds that you get, the price, which, mind you, is still just insane. If we look at the pricing here, Gemini Flash Lite is hilariously cheap. If we compare Flash to a model that's similar in performance, like 4.0 here, it's 25x less expensive for both input and output tokens. That is insane. That's unbelievable. That said, we still haven't seen the pricing for the Pro models because the 2 Pro version for 2.0, not 2.5, is still experimental, and Google doesn't charge for experimental models. So we don't know what the Pro versions are going to look like in terms of price yet, but considering the orders of magnitude gap between Gemini and other models of similar quality, I would expect that gap to continue. I would expect Google to lead in price, despite the fact that they're also now leading in performance. Gemini is so popular in T3 chat that over 1 million messages have been sent to it, which is unbelievable. And if you're curious about cost, that was about $1,200 for 1 million messages. Claude has gotten less than half as many messages, and it's cost us $31,000. Is 3.5 and 3.7 from Claude a better model than 2.0 Flash? Yeah. But is it 60 plus times better? No. Gemini unlocks some crazy stuff that wasn't possible, both due to the crazy context window size as well as the price. It's insane what you can get away with using Gemini 2.0. And I'm excited for a future where AI bills are chasing these prices. There is one other piece here that is worth considering. I'll put it down here. Money. Basically, every company in here, other than NVIDIA, Anthropic, OpenAI, and obviously now Google, has to put a lot of work in order to have enough money to fund these explorations. That's concerning because money, especially nowadays, is not as easy to get as it used to be. Mind you, Grok just had a pretty crazy deal where they landed, they got a crazy commitment for $1.5 billion of spend. That's not money they get immediately. That's money that they're going to get over time from a customer who's using their chips to roll out a ton of stuff. But that's still nothing compared to the money Google can just piss around into stuff. That also means Google could theoretically run at a loss. We don't know if they are because we don't know how much the hardware they're running on costs. We don't know much about the hardware other than that it exists and that it seems to be pretty good because it's theirs. They're not selling it. And that's the biggest difference probably between Google and all the other companies is since they want to win, they can, instead of selling any one of these things, they will instead bundle the whole thing up and sell this to you as an API. OpenAI has their own infrastructure they built in partnership with Azure, but you can host OpenAI models on Azure yourself. DeepSeek has an API that's almost always down, so you're expected to host those models yourself. Anthropic has an API that's insanely expensive and absurd in its uptimes, especially recently with the demand. But you can host their models in other cloud providers like GCP and AWS. Google will never let you use their models in another cloud because Google has their own GCP. That's almost another category I could put in here, like the platform, because Google has an actual cloud platform similar to AWS or Azure with Google Cloud Platform. And as much as I've memed on it in the past, hell, I've memed on it today because it got in my way a whole bunch. It's there and it works. It's a mess, but despite being a mess, it can kind of get out of it because they're so strong in these areas. And it's mind-blowing to me. I've been crapping on Google Cloud for the better part of a decade at this point, but I'm still using it more than ever, and I'm still in that dashboard more than most of the others now because Google won so hard on these categories. Can I say something that makes me angry? Where the fuck is Apple in all of this? All I want is for Siri to answer one basic question. Yeah, Apple is kind of screwed because they were not prepared in any of these categories. Apple has no data because they are such a private company and privacy's always been their focus. So the data they need to train a model themselves doesn't exist. The science side, they have historically underinvested in and underhired in because they don't have the data. So they don't have things like recommendation systems that are good. So they've not done that. Even Siri itself wasn't a thing they built. It's a thing they acquired because they didn't have the talent internally to do it. In their hardware side, despite having incredible stuff, Apple's hardware is entirely focused on how much performance can we squeeze per watt, which does great things for phones and tablets and tiny little laptops like the one I'm doing all this on right here, but it doesn't do anything for this type of inference. And we've seen how hard it is for Apple to release desktop computers that are powerful. They just strap more of the same chip on and hope for the best. Apple's hardware division is innovating like crazy for the devices we have in our pockets, but they aren't doing much of anything for everyone else. So if you need at-home inference, you can strap a bunch of Mac Minis together. It's better than you would expect, but it's still nothing compared to what Grok or Cerebras or NVIDIA and Google are doing. It's just not what they are investing in. So I agree, Apple's position in this market is bad, and the result of their lack of planning is embarrassing. Apple's hardware is good enough that it should be able to run a lot of these things locally, and we've seen that with companies like Ollama. Ollama makes it hilariously simple to just install a tiny little program and run models locally on your computer. And Apple's hardware is capable of doing it at pretty reasonable speeds, but Apple hasn't figured this all out themselves yet. One last thing I want to emphasize with Google. Historically, Google Cloud wasn't what I would call, how do I put this? Tuned in. GCP always felt like it was not really understanding the state of the world. Like we would be out building cool serverless stuff with Next, and they would say, hey, you should try Google Cloud Run. And I would try it, and 20 broken input boxes later and a fundamentally dysfunctional GitHub integration, and I had a broken deployment out. It was embarrassing. That is not the experience I have had with the AI side. Logan, if you guys don't know, Logan has been out and about constantly doing Twitter spaces, being the main point for announcing all of these new things when they happen, answering people's questions, DMing people who are trying to get this all working, really making the AI product function. And AI Studio is so much better than the rest of Google Cloud. It's kind of hilarious when you have to hop out of AI Studio into other Google Cloud product stuff. Like, you want to see how hard your service is getting hit through GCP. You can't see usage data in AI Studio yet. So you have to go into Google Cloud, and then you realize just how hard they have to fight to get out of all these things. I bring this up because the comms around this release have been awesome. This is from Oriol, who is an official member and VP of Research and Deep Learning at Google. His post about this used the Hexagon demo. I think that's awesome. I genuinely like the fact that they're tuned in enough that they see what's going on in this world. They're hanging out with us in Twitter and all these other spaces, watching my videos, hitting me up, taking part in the space as a whole, and showing it actually generate stuff based on what we are talking about. That's cool. This is a level of awareness that I'm not used to from Google. I have not seen them get it like this before, and it's nice to see a Google that's paying attention to what people are actually doing in the space and what we're actually using this tech for. Sorry for the interruption. I might have been a little too nice to Google when I filmed this, because after the stream, oh, hi buddy. After stream, I found some information that makes me a little frustrated. I get why they're doing this because everyone does it, but I wanted to make sure it's clear because I didn't mention this in the video. The thinking capabilities that we see in the model when we use it through Studio are not available as part of the API output. So when I ask a question in AI Studio, hi bud, sorry for the interruption, the cat has feelings too. Here you can see when I ran this, it just immediately spit out the response, even though T3 chat should be able to handle reasoning, which had me suspicious because I thought they had this baked in. Because when I ask the same question here, we'll get this thinking data. This is all of the thinking that it is doing before spitting out the answer. My cat can't stop purring and being needy. I am sorry. So when we're using it through AI Studio, we get all this thinking data. It shows it all clearly here. But when we use it via API, we get none of that. We just kind of have to sit there and wait for the answer. And that sucks. It'd be really, really nice if they were willing to expose that data over the API. But as they called out in their docs, it is not currently available. So, hey, Google, if you guys are listening, please fix this. So once again, 2.5 Pro, incredible model. Google's been working really hard. They're incredibly well positioned, and I would not want to be their competition right now. I say, despite the fact that T3 chat is almost inarguably kind of their competition. So what do you guys think? Do you like the model? Do you hate it? Do you think I'm crazy thinking Google's well positioned here, or do you think they're probably going to win? Let me know in the comments. And until next time, please sub to T3 chat. We got to pay these bills somehow, man.